In my last video, we looked at an introduction to projectiles. In this video, we're going to work through a range of exam style questions on projectiles. If you haven't seen the last video, please check that out as there's some key learning points in there. Let's start off. We're told a cricket ball is hit from the floor of the sports hall, which has a height of 6 metres. The initial velocity of the ball is 20 metres per second at an angle of 60 degrees above the horizontal. The question says assume that the cricket ball is a particle which moves only under the influence of gravity. In part A for 5 marks, we need to show that the ball hits the ceiling of the sports hall approximately 0.389 seconds after it was hit. Let's have a quick sketch of what's going on here. What we're going to have is the floor. We're going to have the cricket ball, which is hit from the floor, and if it completed its flight, the flight path would be a parabola and it would look something like so. So we'd have this symmetric curve. We have now an angle of release. The angle of release is 60 degrees and the velocity or the speed of release right here is 20 meters per second. So this is going to be 20 meters per second, and that now is at an angle of 60 degrees with the horizontal. What we've got in this particular case is a ceiling, and we can put the ceiling on like so. So if this ball was able to continue its path without the ceiling, we wouldn't have it hit. So it followed this path. And all I'm going to say now is that this height right here is going to be 6 meters. So let's go ahead and solve this problem. We can consider now the motion in the vertical plane. I'm simply going to collect information using Suvat. If we consider the vertical velocity, that is going to be 20 sine of 60 degrees. We know the acceleration from the last video is going to be negative g, or negative 9.8 meters per second squared, and we have a displacement of positive 6 meters. So I've taken 6 now to be positive as I'm going upwards. We know that S is equal to ut minus 1/2 gt squared. So all I'm doing is using the constant acceleration equations, and I'm considering motion now in the vertical plane. So if I plug these in, we're going to have 6 is equal to 20 sine of 60 degrees. This is going to give me 20 times by root 3 over 2, which is going to be 10 root 3. The sine of 60 degrees is what we call an exact value. So we're going to have now ut, which is going to be 10 root 3t. G is 9.8, so 1/2 of that, we've got to negative 4.9 t squared. We've got a quadratic in t, 4.9 t squared minus 10 root 3t plus 6 is equal to 0. So we can go ahead and solve this equation. From here we can say now that A is going to be for 4.9. We've got B to be negative 10 root 3, and we've got C to be 6. So plugging this into the quadratic equation, we can say now that T will be equal to minus, then we're going to have the minus 10 root 3, plus or minus the square root of negative 10 root 3 squared minus 4 times by A, which is 4.9, times by C, all over 2 lots of A. So 2 lots of 4.9. This is simply using the quadratic equation. So let's look at that in a calculator. We're going to have now negative, negative, so we're going to have 10 root 3. Then we're going to have now plus the square root of negative 10 root 3, which we need to square. And we are going to now subtract from that 4 times by 4.9 multiplied by the 6, and we're going to put that now over 2 lots of A, which is 9.8. That gives us now 3.14, so let's put that on. T is equal to 3.14 dot dot dot, or we're going to have T hopefully equal to the other answer, and we can find that by switching over this symbol now to the negative. So we end up now with 0.389, so 0.389, and after that we're going to have the following. So we've got 280, 986, 280, So 280,986. And remember, this is in seconds. If we consider what this is saying is, essentially, we would reach this point on the first point where we were 6 meters above the ground, which is the 0.389 ... And then the other one is just here, and that would have corresponded to the time of 3.14 seconds. So what we would have had is these 2 points, but quite clearly, if it hits the roof, it's going to disturb this path or trajectory, and we're going to have this value. Okay, in part B for 2 marks, we're asked to find the horizontal distance travelled by the ball before it hits the ceiling. So we're now considering motion in the horizontal plane. If we look at this, collecting information using SUVAT, we saw in the last video that the horizontal acceleration was 0. We know that the horizontal component of the velocity is going to be 20 cos of 60 degrees. Cos of 60 degrees is going to give us now 1/2. 20 times by 1/2 is 10. We've seen, using the constant acceleration equations, for horizontal motion, S is equal to now U multiplied by T. So U multiplied by T, we can substitute in this value here for T 0.389 ... and that will give us now the horizontal distance, or the range of the ball. Well, it's horizontal distance really, as the range, you could probably say the range is more in keeping with the full flight path or full trajectory. So we can say S, the displacement in the horizontal direction, is going to be 10 multiplied by the 0.389 ... and we can say that that will be, now writing this on here, 3.89, so 3.89, and that will be now meters per second. Sorry, my apologies, we're looking for the distance, so that's going to be 3.89 meters, and that is correct now, so putting that on, and that is to 3 significant figures, so 3SF. So all I've done is simply plug that in. We're asked to find the speed of the ball just before it hits the ceiling. So let's think about what we've got here, and we can draw this up. So again, sketching this out, we'll have the following. I'm going to have now the horizontal, and the horizontal velocity remains constant. We know the horizontal velocity has now no change as the acceleration is 0, and then what we're going to have is a vertical velocity. So this is going to be our resultant. We can put on here that this is going to be 20 cos 60, which is going to be 10. So that gives me now 10 meters per second. Using now the vertical motion, V is equal to U plus AT, we can say now that this one is going to be 10 root 3. So V is equal to U. Remember, this is U. Then we're going to have minus G multiplied by this time of 0.389. So ... and so on and so forth. So all I need to do at this stage is use Pythagoras, and we can find the resultant just here. So if I do that now, using this answer in the calculator, I can say that the velocity, or the speed, let's put down here, so the speed will be equal to, the square root of 10 squared, plus now the quantity 10 root 3 minus 9.8, which is our G, multiplied by our 0.389 ... which we're going to square. So let's go ahead and calculate that, and we'll put it into the calculator. So what I'm going to do is just store this, shift store A. So what we have here, and I'm going to just write this out, we've got 10 root 3. So this is what we call an exact value, so 10 root 3. And then we're going to have minus 9.8 lots of this value which I've stored of A, and that's going to give us 13.5 and so on and so forth. So we're going to have the square root of 10 squared plus 13.5 ... which we're going to square. So just checking that, 13.5. So if I square that and add it to 100, that's going to give me now 282.4. So let's write this in. 282.4. We'll take the square root of that and it will give us the answer. So let's do that, square root of the answer, and that's going to be 16.8. So 16.8 meters per second, and that is correct to 3 significant figures. So that is my answer, and we've worked that out from there. So total of 12 marks on the question, and that is exactly what we would do. If we were asked to find the angle, we could go ahead and find the angle by simply taking the inverse tangent of this quantity right here divided by this one here, and that would give us now the angle that the velocity or the speed makes now with the horizontal. Okay, let's have a look at another question. A tennis ball is hit from a height of 2.45 meters above horizontal ground. Initially it travels horizontally at a speed of 20 meters per second as shown in the diagram. In part A it says show that the time taken for the tennis ball to reach the ground is 0.70 seconds, correct to 3 significant figures. So let's go ahead and collect some information using SUVAT. So if we consider now the vertical motion, S, U, V, A and T. Initially we only have a horizontal component of velocity, so we're going to have 0 to begin with. So this is going to be my initial velocity vertically. If we consider gravity, that is the acceleration, and that will be acting downwards. So we're going to have negative g. If we now look at the displacement is going to be negative 2.45 meters. So all we're looking to do is find t. We know that s is equal to ut minus 1/2 gt squared. Remember, this comes from s is equal to ut plus 1/2 at squared. So we've got now negative 2.45 will be equal to ut, which is simply going to be 0. Then we're going to have, now subtracting from this, we're going to have the minus 1/2 gt squared. We just have to be a little careful here with the positives and negatives. So if I just plug this in, we're going to have minus 4.9 t squared. So we can say that t will be equal to plus or minus the square root dividing both sides by negative 4.9, 2.45 over now the 4.9. Clearly it's going to be the positive value as it's time, and we can show that in the calculator. So taking the square root now, so we've got the root of 245, so 2.45, so 2.45 divided by 4.9. Let's get into the denominator, 4.9, and that is going to give me now root 2 over 2, which is 0.707. So root 2 over 2, let's put that in. So root 2 over 2, or 1 over root 2 if you like, which is going to be 0.707, and that is now to 3 significant figures, and that will be seconds. So that's the first part done. We simply considered the vertical motion. We're asked to find the horizontal distance travelled by the ball when it hits the ground. So let's now consider the horizontal motion, collecting information using SUVAT. Initially the velocity is purely horizontally, so we can say this is 20. We know that the acceleration is going to be 0, and we can say that this is going to be root 2 over 2. I like to keep the exact values. So the horizontal distance is given by s is equal to u multiplied by t. This is from s is equal to ut plus 1/2 at squared, but of course, as we saw in the last video, acceleration is 0, so we can simply say that s is going to be 20 multiplied by root 2 over 2, so s is going to be 10 root 2. Root 2 is about 1.4, let's just do this, 10 lots of root 2, so this is going to be about 14.14. So this is going to be now 14, so s is going to be 14.1, and that will be meters, and that is correct to 3 significant figures. So that's what we've got. We're asked to find the angle between the velocity of the ball and the horizontal when the ball hits the ground. Again, all we need to do here is a simple triangle. So we know that the horizontal velocity will remain the same, and we're going to look now at the vertical velocity. Drawing a quick right angle triangle, this is what we're going to have. This is going to be my angle right here, so we'll call this angle theta, and that is the angle it makes with the horizontal. We know that this is going to be 20. This one right here is going to be 0. That is the initial velocity. So all I'm doing at this stage for the vertical is doing v is equal to u plus at, or if you like, the velocity is equal to u minus gt. So this is going to be 0 minus 9.8 multiplied by t, which is going to give us the root 2 over 2. So we can say from here now that the angle it makes with the horizontal is going to be now the inverse tan, and we're going to have now this value right here. So if I do half of 9.8, this is going to be 4.9 root 2 divided by 20. So all I'm doing is the inverse tan of the opposite over the adjacent of a right angle triangle. So if I wanted to find the velocity down here, I would simply do now this squared plus this squared square rooted. So that's going to give me 20. You might have noticed I've dropped the negative. All we're doing is going to say that this angle is going to be below the horizontal. So making sure the calculator is in degrees mode, shift mode 3. We'll take now the inverse tan, so shift tan, inverse tan, and we're going to have 4.9, and that will be root 2 divided by 20, and that will give us the angle of 19.1 degrees. So we can say now that theta is going to be equal to 19.1 degrees, and that is correct to 3 significant figures. So just popping that there, and we found that. So again, we're looking at another 9 mark, quite a big mark question, and that gives us our solution. Okay, let's move on. In this question, we're told a golf ball is projected from a point O with initial velocity v at an angle alpha to the horizontal. The ball first hits the ground at a point A, which is at the same horizontal level as O, as shown in the diagram. So we've got a parabola here, we're starting and finishing at the same height. It is given that v cos alpha is equal to 6u and v sine alpha is equal to 2.5u. Just consider now, this is the initial velocity in the horizontal direction, this is the initial velocity in the vertical direction. So all I'm going to do is just collect up my suvat and write this in before I move forward. So I can say that this is 2.5u, or 5 over 2u. We know that we've got negative g. If we then go horizontally using suvat, s, u, v, a and t, the acceleration will be 0, and we have 6u. So in part A for 4 marks, it says show that the time taken for the ball to travel from O to A is 5u over g. So let's consider now the vertical motion. If we look, the displacement is 0. So plugging this in, I have 3 of these values. So all I need to do is go ahead and find t. So using s is equal to ut minus 1/2 gt squared, we can say 0 will be equal to 5 over 2 ut. All I'm doing is subbing this in, minus 1 over 2 g, and then we're going to have t squared. We can factor this, so we can factor out 1/2 t, so we can write 1/2 t. That will give me 5u minus the g. That then needs to be multiplied by t, so we can say that t is equal to 0, or 5u minus gt will be equal to 0. So from here we can simply say that 5u is equal to gt, and that t is equal to 5u over g. So 5u over g. And that shows that we can do it, and that's one way that you could do it. Okay, we're now asked to find in terms of g and u the distance OA. So we're considering now the horizontal suvat constant acceleration equations. So we know that this value right here is going to be 6u. We know that the time is 5u over g, and we know that the acceleration is 0. So if we're looking for the distance, s for displacement is ut plus 1/2 at squared. We know for the horizontal motion we can simply write s for displacement, or the x value is u multiplied by t. So we've got 6u multiplied by 5u over g, and that's going to give me now 30u squared over g meters. Okay, we're now asked to find v in terms of u. The question carries 2 marks. If we think about this, we've got horizontal and vertical components just here. So what I've got then is the following. I know that at this point right here, this one right here, we're going to have the 6u. So we're going to have 6u in this direction, and we're going to have 5 over 2 in that direction. So we can say that 6u squared plus 5 over 2u squared must be equal to v squared. So 36u squared, and then we're going to have plus on here, so let's add this one up. That's going to be 25 over 4u squared is equal to v squared. If we add these together, that's going to give me now 144 plus 25, 169 over 4u squared is going to be equal to v squared. Square root in both sides, 13 over 2u will be equal to v. That's probably a little bit of a long way round, but essentially it's this one squared plus this one squared, square rooted. I'm open to any better examples of that one just there. Okay, so that's 2 marks then. It now says, state in terms of u the least speed of the ball during its flight from O to A. We've already seen in the last video that this is going to be at the point just here. So if I just get rid of this, we have now vertical and horizontal velocities here, and the vertical gradually gets smaller and smaller. And we saw that we had an initial one which was quite big, then we had a slightly lesser one just here, a slightly lesser one just here, an even smaller one just here, very little here, and then all of a sudden at the top, and this is at the top, and I just draw a line, we had a vertical velocity of 0. The only one that we had acting is now the horizontal, which is given it to be 6u. So we can say at this point right here, all we have is 6u meters per second. So that now is going to be the least speed of the ball. Remember, we're looking here at speed. We know that velocity is going to be now negative and getting larger negative, symmetric with the other side. But this is our answer because we're at the top and the vertical component of velocity is 0. So the least speed is going to be 6 meters per, or 6u meters per second on that one. Okay, let's look at another one. On this one, it says a golf ball is struck from a point O with velocity 24 meters per second at an angle of 40 degrees to the horizontal. The ball first hits the ground at a point P, which is at a height of h meters above the level of O. So there we go, that's what we've got. Horizontal distance between O and P is 57 meters. So here's O, here's P, and here's H. In part A for 3 marks, we need to show that the time that ball takes to travel from O to P is going to be 3.10 seconds. So 3.10 seconds, correct to 3 significant figures. Okay, this time we're going to start off now with the horizontal. So if we think now, the horizontal here, collecting the information, let's just put this on. Horizontally, we've got 0 acceleration. We've got a displacement of 57 meters. We've got an initial velocity of 24 cos of 40 degrees. And we need to show now that the time taken, which I'm going to call t, is 3.10. So from this, we know that s is equal to ut horizontally, as we've got no acceleration. So we can say that 57 will be equal to 24 cos of 40 multiplied by t. So from here we can say that 57 over 24 cos of 40 will be equal to t. Now we can show these values if we want on a calculator. So if we do 24 cos of 40, so 24 cos of 40, that's going to give me now 18 point, what have we got, 18.38, so 57 over 18.38 dot 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 is equal to t, and that should now give us that value. So if we just do 57 divided by my answer, let's put the answer, 3.10, so 3.1003 dot 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 is the time. So that's all we need to do on that bit. Okay, we now need to find the value of h. So this time we're considering in part B the vertical motion. So if we think about the vertical motion, we're going to have h. So we're looking at this displacement from 0. So let's put in S, we've got H, U, V, A and T. I'll just tidy that up so we can put this in. So we've got S is equal to this height. Let's just do that. So S, we'll put that there. That is going to be H. We know that the acceleration is going to be now negative g. We've got an initial velocity. The initial velocity is going to be 24, and we're going to have sine of 40 degrees. We've got this time right here, and this time is our 3.100 dot dot dot, which we can store in the calculator. So I can say now that S is equal to ut minus 1/2 at squared. So h will be equal to 24 sine of 40 multiplied by the time, which is going to give us the 3.1 dot 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 and so on and so forth, minus 1/2 at squared. So half of g is minus 4.9, 3.10 dot 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 dot, which we're going to square. And that now will give us this height right here. So let's go ahead and do that. So if I just store this, shift store A, that's going in the calculator. So what we've got is the following. We've got 24 sine of 40 degrees, and we're going to multiply that by A. We are then from that going to subtract now 4.9, then we'll have A squared. So that is going to give me now on here 0.729. So 0.729, let's put that in. So what have we got? 729, and that's going to be meters correct to 3 significant figures. So that's what we have right there. Okay, we're now asked to find the speed with which a ball hits the ground at P. So again, let's just take this. We're going to have now the horizontal, and we're going to have, let's do that one. We'll have a horizontal, and the horizontal velocity will remain the same, and then we're going to have a vertical velocity. So we know from here that this remains the same at 24 cos 40. So 24, so writing this in, 24 cos of 40. If we take this one, and I'll just move it so we can fit it on. Let's just take that down here. What we're going to have with this one, and just putting it in place, let's put that there. We're going to start off now with 24 sine, let's put this in, so 24 sine of 40 degrees minus now g times by t. So this is v is equal to u plus at for the vertical motion. V is equal to u minus gt. So minus 9.8 multiplied by a time, which is the 3.1 dot dot dot, and so on and so forth. So I can say that the velocity, which is the resultant just here, was going to be now, or the speed I should say, the speed is going to be the square root of 24 cos of 40 degrees, which we need to square, plus the square of 24 sine of 40 minus the 9.8 multiplied by 3.1 dot 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 dot, which we're going to square. Hopefully that makes sense. This is simple Pythagoras now to find the third side of a right angle triangle. So if I do that in one foul swoop on the calculator, remember I've got this value just here. So this is my 3.1. So we're going to have the square root of 24, and I would suggest in the exam just writing a bit more than this, 24 cos of 40, which we need to square, plus 24 sine of 40, which is the initial velocity in the vertical direction, and then we're going to have minus 9.8 multiplied by our value, which I'm going to put in here, and we need to square that. So that's going to give me 23.7. So let's put this on. That's going to be 23.7. And let's check that I've got that. So that's correct to 3 significant figures. So that's what we have here, which seems fairly logical if we think about it now. If this was symmetric, it would hit the floor with a speed of 24. It's going to hit the floor now, or hit P at this point right here, at 23.7. So even if we were wrong, it's kind of realistic. And then all we've got then is this for our 5 marks. So find the speed, that's the speed. And now we need to find the angle between the direction of motion and the horizontal as the ball hits the ground. So we just need this angle right here. So this angle, theta, so let's put this here, theta is going to be equal to the inverse tan. So the inverse tan of 24 sine of 40 minus 9.8 multiplied by the 3, divided now by the 24 cos of 40, and that will give us our answer. So we're just going to find that angle, so we'll do the inverse tan, and again just check your in degrees mode. 24 sine of 40 degrees, then we're going to have now minus the 9.8, so what have we got on here? Minus 9.8 multiplied by a, and we're going to divide that now by 24 cos of 40 degrees, so 24 cos of 40 degrees, and that will give us what we're looking for. So let's put that in, that's the one I want. And that's going to give us this angle right here, and that's going to be 39.1 degrees. So theta, 39.1 degrees. So theta is equal to 39.1 degrees, and that is now to 3 significant figures. Now if we look at that realistically, that seems pretty good given that that one is 40, and if it hits the floor, we've got now a symmetric graph or trajectory, and that would have been 40. So even if I'm way off the mark, I'm not way off the mark, even if my calculations went wrong, these seem fairly legit. So there we go, 4 different exam style questions on projectiles, and we've just looked at all of the information that we picked up in the last video. If you're not comfortable with that, please do go back and watch it, as some of the key learning points were in there. This has simply been a run through of some exam style questions.